and record. So I'm recording now, so no more cussing. What? Let's talk about those two examples. I asked you to do example 1, example 2 from section 2.5. Yes? Okay. Here we go. Example 1 says that 57% of all law students who take the bar exam will pass. Okay? Bob is a student who will take the bar exam. Okay? So to be a lawyer, you have to take this test, you have to pass it. So you have 57% pass. What percent not pass?
43.
How much?
43.
43? I like it. And we know this because the two of them have to add up to be 100%. That's what makes a binomial event. There's two different outcomes. You have that it will, and you have that it won't. That makes sense, first of all?
Yeah.
Good? Okay. All right. He will pass on the first try. So pass on the first try. So basically, it's going to be the 0.57 times 0.43. So we're going to take this and we're going to raise it to the 1 minus the outcome we want. So the 1 minus 1. And so that means I have 0.57 times 0.43 raised to the 0 power. What is 0.43 raised to the 0? 1. So then what's 0.57 times 1? So he has a 57% chance of passing this test first time through on the first try. So that's pretty easy. So the basic equation you're doing is the probability you will times the probability you won't raised to the n minus 1, the whatever event would take place. If we wanted to know what is his chance of passing this on the 50th time he took it, it would be 0.57 raised to the 0.43 raised to the 49th power because 50 minus 1. Okay, then we can go through that. Letter B, he'll pass within the first 3 tries. Pass within the first 3 tries. So he has attempt number 1, and attempt number 2, and attempt number 3. Okay? And this might make, having a 57% pass rate, some people might say, well, why should I even take it if about half the people aren't going to pass it the first time? This might make you feel a little bit better, because when you take these tests for med school and law school, things like are getting done, financially, it's a good amount of money. And it's not like the ACT or SAT that costs you, 20, 30, 40, 50 bucks. I don't even know. I'm sorry, I don't know. $50? The MCAT for the medical to get into med school is like $600 or $700 each time you take it. So then, should that deter somebody from not going into medicine or not? No, it should. Keep going. So we knew that. What was this probability? 57. So we already had found that on the previous slide. And then we're going to add it to 0.57, 0.43. What is 0.43 going to be raised to with that? 2 minus 1, which is 1. And then we're going to find this one, which is going to be plus 0.57 times 0.43. Being this is the third time, what should we be raising the 0.43 to on this one? Second. Can somebody work that out on a calculator? Should be able to put that whole string of events on your calculator. The nice thing is the larger calculators will allow order of operations to take place with the exponents without any problems. So item 1, is it above 57%? Well, yeah, you're taking 57%, you're adding something to it, so it's definitely going to be above that. Yo! Wave to the camera. Wave. Remind me to mark you toddy. When I get done. Yep. The whole thing? Yeah, you can put this whole thing in your calculator. We get an answer yet? 0.92?
Yeah.
We got one person saying, is it 0.92 exactly, or did it go a few more places?
0.92.
04? I'm thinking that. Do you guys get that or no?
Yes, sir.
So, what do you think? Is it better that you... Can we get verification that that's right? I don't know.
I got it.
Not yet?
No, I got it.
You got it? Okay. So, is it worth... You've gone through law school. You have this bar exam to take. In the state that you're in, 57% pass rate. Okay? So is it worth you continuing to invest money on this test? Yeah. Is there a chance that you won't pass it after this third time? Yeah, you got an 8% chance you're not going to pass it still. But is it worth for you doing? Is it worth you saying, well, I will be as a junior partner, or not even a junior partner, but somebody who's just a low end, might have gone through law school, not passing the bar exam, working for a fraction of what the people at the law firm are making. Is it worth you to continue to take it? I think so. Okay? A 92% chance that we pass this after 3 tries. Pretty good shot. Okay, and then letter C, he will pass after second attempt. He will pass after the second attempt. Any ideas? If I took this test 10 times in a row, is there still a guarantee that I passed it? No? If I've taken it 100 times, there's still a guarantee that I pass it? There's no guarantee that you're going to pass it. Theoretically, the more times you take it, the higher chance you have of passing it, because obviously you will. If you take something and there's similar, problem number 1 is a similar type of question as all the number 1s on every test. Problem number 2, theoretically, you should be able to say, I need to brush up on this stuff a little bit and study a little bit harder and really figure out what the thought process is in order to pass these questions. Okay, so he will pass after the second event. So that means that probability 3, probability 4, probability 5, plus probability of infinity have not taken place. How can I even do that? How can I do that kind of math? How can I do infinite amount of problems right now? After a second attempt. So I like it. Lenny, you nailed it. It's going to be 1 minus the probability, what is the probability of 1 plus the probability of 2. Okay? So that's what we're going to do. That's going to eliminate having to do an infinite amount of problems. And I know you as well as I do. I'm pretty sure you don't want to do an infinite amount of problems. So 1 minus probability 1, probability 2. Probability 1 we already found is 0.57. Probability of 2 is 0.57 raised to the 0.43 to the 2 minus 1, which is 1. Someone do that for me right there. Part this underlined. Don't say you don't have a calculator. A lot of clicking keys. I don't have a lot of shouted out answers. 0.2 what? 0.2451. Agree? Okay. 1 minus 0.457 minus. So remember this. I need to distribute that minus over those. So go 0.57 plus 0.245. Go 1 minus whatever that comes out to. How much?
7549.
0.7549?
Yeah.
Okay. So 75.5% chance. Takes you 2 tests to do. Can you budget time?
Oh, sorry. No, that's wrong.
That's wrong?
Yeah, I didn't add them.
Oh, okay.
That was my
Oh, did you got 1 minus that? Okay, so this is still 1 minus that, right? Which is? Say what?
0.1849.
0.1849. So about an 18.5% chance that he will pass after his second attempt. Wow. Let's keep going. Basketball player, we like going to this basketball player. I guess it's good that we're in basketball season when we're talking about basketball players. I wouldn't have your attention that way. All right, basketball player typically makes 82% of his free throws. Excuse me. Assuming each free throw is independent, fine. The probability that his first miss is his third shot. So you got makes it is 0.82. Does not make it is what? 0.18? Ooh, we got a blue screen now. Be on camera. All right. So, what is the probability that he will miss the third shot? Am I worried about the first or the second shot? No. Does it say that his first shot misses his third shot? No. This is just saying this person's going to the line. It's probability that the third time he goes to the line, he's missing. Okay? So missing is this, right? Missing's that? Yes? So is the 0.18 going to be raised to the second power, or is the 0.82 going to be raised to the second power?
I'm just wondering, is every shot independent, would it just be 18% every time?
Yeah, but this is assuming he's already taken his first 2 shots. So now we're just trying to do the math behind it. You're absolutely right, saying so if you came walking in and this is now the third free throw that you're witnessing, then you're like, okay, you're looking at it as independent. But now we're trying to take the string of events during a whole game. Yes, you're absolutely right that the last basketball does not remember making it or not. We're just trying to figure out what's probability that this third shot is made if the first and second have already been taken. Whether they're made or not, we don't know. Just that's what we're running through. But I like it. I like how you're thinking. So is the 0.18 the raised exponent, or is the 0.82 the raised exponent? What do you think? So the equation is probability of success times the probability of not success, and this is raised to the n minus 1. What's success in this problem? What's success as far as this portion of the problem? Success is 0.18 because we're asking that he will miss his first or his third shot. So success in this problem is backwards from what you're thinking. You're thinking that, oh, he makes it success. Success in terms of this problem is this. So what is the probability he misses? 0.18. 0.18 times 0.82. What's 0.82 going to be raised to? The what? The second. Good, because n minus 1. How much? 0.121? Thank you. So, being that 3 events are taking place, or 100 events are taking place during this game with this person's free throw shooting, the probability he misses his 3rd shot is 12.1%. It's not too bad, is it? And those of you who did the problem, you want 0.18 times 0.82, and the 0.82 is raised to the 2nd power, yes? Okay, just making sure. Letter B. What is the probability he will miss his 5th shot? What am I changing on this problem? The 2. What's the 2 going to change to? What? 4. So 0.18 times 0.82 raised to the 4th power. Help me out. 0.0813. So it has an 8.1% chance of missing his 5th shot. Why is the probability going down? You said everything's independent. You're right. But the more you take, you have a higher chance of you're a better free throw shooter than most people. You're making 82% of your shots. So if you had someone who is going to guess at this, not knowing what you're doing, but knows what your free throw percent shooting is, they can kind of determine. Now, if someone came walking up to you, Caesar, you good free throw shooter?
I'm alright.
All right, where do you think you fall?
Like 70%.
70%? So let's move you up to the big leagues going 8.82.
Alright.
Do you think that if I walked up to you, it's your 5th shot, coach calls timeout, y'all go around the thing, I walk over and I interrupt coach, hey coach, let me talk to Caesar. After he gets done hitting me in the back of the head 19 times, I'm going to let you know you have an 8.1% chance of missing the shot. You're like, no, man, we're going to nail it, pal. So that could influence the whole outcome. But this is like, if you didn't know, if I was being that math nerd in the stands going, dude, Caesar's hitting this. I know that you have an 8.1% chance of missing your 5th shot. I might lean over to the person next to me saying, I'll put $20 on this that he hits it. So take me up on that action. I might win $20. I'll give you 10. Find your speed. All right. Now wait a minute. The probability that his first miss, hang on. The probability that his first miss is before his 5th shot. So now we're taking events that haven't taken place yet. We're going to put the probability of this taking place, and we want to know what the probability that the first miss happened before the 5th attempt. Does that make sense? So the probability there is a miss before the 5th shot, or 5th attempt. Ooh. Uh-oh. What do you think? How are we going to do this? I like the 1 minus the 10. Is that really the way we need to go? I think 1 minus is a good attempt, but we're only 5 attempts into it. I think I could get away with this. Probability of miss number 1 plus the probability of miss number 2 plus the probability all the way up to the probability of miss number 4. little nervous with this. It's starting to blink at me a little bit. I shouldn't have feelings. Okay? So what is success in this problem? What is success in this problem going to be? Is the making the free throw your success in the problem, or is the missing the free throw your success in this problem? Yes. Okay? So, 0.82, make it. 0.18. Uh-oh. Come on, baby. Uh-oh. 0.18, miss. Okay? So probability you miss the first is what? Just 0.18. You agree with that? Probability you miss the second is going to be 0.18 times 0.82 raised to the first. Why is it first? 2 minus 1. And then probability of 3, 0.18 times 0.82. So my third attempt is going to be raised to the second, plus 0.18 times 0.82 raised to the third. I think you could plug that whole string of events into the larger calculator and give me an answer. I think. An answer? Yeah.
0.5478.
That's what I got. 0.5478 roughly. So 54.78% chance. Person's at the line. You come walking into that basketball game. Your friend says this is the 5th time they've been to the line. Probability that your miss, or that shooter's miss, had missed before you had walked into that game is close to 54.8%. Huh. Letter D. You won't see letter D, this kind of thing on the test. You won't have to use this on a test, but I just want to run through it. What is the probability that he'll miss after his 8th shot? So miss after his 8th shot. So that's like the probability of 9 plus the probability of 10 plus the probability of infinity. So this is going to be 1 minus the probability of 1, 2, probability to 8. Is this still a lot of work? So being that we have a whole bunch of outcomes that are going to take place, rather than doing the whole thing on our own, if you plug this, hey, we got the light color back. Oh, hey. Whoa. Okay, you're going to plug this into your calculator. Okay, you're going to plug this into your calculator. So in this particular scenario, what is the probability you miss after the 8th shot? Does that mean, could you have missed before then? Yes. What is the probability that Oh, the first, or no, you have not missed yet. So what's the probability that you've been to the line 8 times, you made them all? What's the probability you missed beyond that? I'm going to take 1 minus whatever this answer is going to be. What do we plug in for this answer? The probability of that miss is what? 0.18. How many shots are we looking at going beyond? 8. So on your calculator, how do you find this? It's under catalog. Good. So go under second 0 into catalog. If you hit the letter G on the alphabet, it'll take you down to geometric whatever it says. What did you get?
0.7855.
0.7855.
I'm sorry, 79. I said it wrong. Just go. 79. 0.7955.
0.7955.
I said the wrong thing.
Gotcha.
You guys
And what's 1 minus that?
0.2044.
So that is the probability that your first missed shot is after your 8th shot or beyond. Huh. Interesting. Okay. What I'd like you to do now is we are going to go to the very last page of your chapter. Very last page of your chapter. It's worksheet 2.7. Worksheet 2.7. But go to number 3. Let's go through these together. Let's figure these out together. So, worksheet 2.7, problem number 3. Let's have double L. Read us number 3 on worksheet 2.7, please.
The shirt company has 4 designs, each of which can be made with short and long sleeves. There are 6 color patterns available. How many different types of shirts are available?
Thank you. How do we do it? How do we do number 3? How much?
4 times 2 times 6.
We have 4 times 2 times 6. Somebody use the choose thing. What is it? Which is it? Let me ask you this. Did I have like 10 shirts that I was going to choose 4 of them to take with me on the trip? Did it say that? Or did it say, at this shirt company, how many different shirts can we make? We have 4 designs of each shirt. You got the one with the pocket, one without the pocket, one with the pocket on the right side, one with the pocket on the sleeve. I don't know. I have no idea. There are 6 color patterns. And then you have short or long sleeves. Short or long sleeves are 2 different shirts. So if I multiply 4 times 2 times 6 together, I'm going to get 48 different shirts. Different shirts I can make. So this is that universal counting thing. Glad I remembered to put the R in there. All right. How many ways can a baseball manager create a batting order of 9 players from his roster of 15? Why is it 15P9, not 15C9? It talks about an order. Okay, the order is important in basketball or baseball. Excuse me. So 15P9 is for number 4. Somebody do that real quick for us.
1,816,214,100.
That's an awful lot of ways to line up. If you had those 15 people sitting there, 15 people is about this part of the class. If I said, okay, order's important, how many different ways am I going to go 1 through 9 with you guys? We're going to be sitting here for a while. 1,816,214,400. So baseball lineups, order is important on that. But if I were to say, hey, how many different ways could I pick 9 people from a group of 9 or from a group of 15? That's going to be choosing. I'm just trying to select a certain portion of people without assigning them your number 1, your number 2, your number 3. Okay, so if I took 15 people over here and said, okay, I'm going to pick 9 of you. I need 9 of you to go out in the hallway. Whatever order you want to go out in the hallway with, that's going to be a combination. If I said, okay, of the 15 of you over here, I want, how many different ways can I have person number 1, number 2, number 3 in order in line? Okay. Number 5, a teacher. What does number 5 say? Watson, number 5.
It says, a teacher has a class of 14 boys and 13 girls. How many ways can he select a group of 4 boys and 4 girls to run the next activity?
Okay. So we have the happy kind of class. Okay, we're going to do stuff. You 14 girls, I'm going to select, or you 14 boys. We're going to pick a couple of yous. You 13 girls, we're going to pick some of yous. Okay? Is there any order to this madness? No. Am I saying, okay, boys, there's going to be a president, a vice president, a treasurer, and a secretary, and girls, we're going to have the same thing. President, vice president, secretary, treasurer. There's no order to this. I'm just going to select 4 of these guys. I'm going to select 4 of these girls. What am I going to use? Choose. So I'm going to go 14 choose 4 and 13 choose 4. And what am I going to do with these? I'm going to multiply them. When would I add? What word has to be in there for this add? Huh? Or. Good. Is or in there? No. So I said to the class, okay, there's 14 boys and there's 13 girls. I want to pick 4 people. So how many ways could I pick 4 boys or could I pick 4 girls? I would add them. But now I'm not adding. I'm going to multiply them together because I want to know all of the combinations of boys and all the combinations of girls. I have to multiply their outcomes together. Did someone get me an answer on this? Yeah.
715 715.
715 715. That was multiplied together?
Yes.
Sweet. Kind of a lot. All right. How many ways could the letters in the word math be organized to create 4 letter arrangements where I'm not repeating? Has to be in order, huh? So what'd you get? I heard 4P4. Someone mumble 4C4. Which is it? Huh? P? Okay. What'd you get? 24? Here's where you know you make a mistake on this. What's 4C4? What's 4C4? 1. You know right then and there you made a mistake. There's not just one arrangement of 4 different letters. Okay? What if a letter had repeated? What should I do? Divide by that number factorial. Okay? And maybe we'll come to that. Oh, yeah, look at that. Number 7. How many ways could we do that? So 5P5, which is the same thing as 5 factorial. You agree? What do I need to divide by? And another 2 factorial. Why? Yeah, you have 2 of the same. Hey, when would I multiply out front? When would I multiply out front? If I had to say a T has to be the first letter, then you'd multiply by 2. Okay? Or a T has to be the last letter. Okay? So 5 factorial is 5 times 4 times 3 times 2 factorial over 2 factorial, 2 factorial. One of the 2 factorials cancels out. 2 factorial is just 2, right? 2 goes into 4 twice, 10, I got 30. I think that's right. You have to do it my way? No, your calculator's going to handle it nicer the other way. How many license plates can be made if there are 3 letters followed by 3 numbers with no repeats? Okay, this is different than what was on the quiz, right? Because I think the quiz had the numbers could not repeat, so you had to go 10, 9, 8, and the letters could, so you had 26, 26, 26. But on this one, I don't want anything to repeat. So 3 letters followed by 3 numbers, no repeats. 3 letters, 26 times 25 times 24 times 3 numbers. How many numbers are we starting out with? 10. And then a lot of you get confused why there's 10. Why is there 10 digits? 0 is a number, so 10 times 9 times 8. I don't have that worked out, but I think you guys could do that. Number 9, an Oscar pool, there are 5 awards. Best Actor and Actress, Best Supporting Actor and Actress, Best Picture. There are 5 nominees in each category. How many possible voting combinations are there? Uh-oh, wait a minute. So I have 5 nominations in each. This has a curveball to it, and I won't do this to you on the test. What's the curveball? So we have 5 combination 1. Why are you saying combination though? Because it says combination. But yeah, we have some sort of order. I'm not going to do it on the test. I would say this one should be done. Actually, I'm not going to multiply by 5. I'm going to raise it to the 5th power. Sorry about that. So being it says specifically the word combinations, I think you should default to combination, even though there's an order to it. I think that's a nasty thing to do to people. I wouldn't do it to you. I'd actually probably accept both answers if you decided to go on both. If I choose 1 is what? If I choose 1 is what? 5? 5 to the 5th power. 5 times 5 times 5 times. Say what? Okay. Sweet. Last problem I'm going to do. I think you guys are well prepared for this test. There are 30 people in your class that are voting for a president and vice president. How many outcomes are possible? 30 what? 30 permutation 2. Why is it 2? Because there's only 2 positions. Why is it not combination? Because we have an order to them. 30p2 is what? 870? So, guys and girls, if at the least you study 3 through 10 that we just did, and the 2 examples that we worked out earlier, I think you're going to do, out of 30 questions, I think if you legitimately feel good about those, of the 30 questions, you should be able to pull a 25 out of 30 without much more effort. Okay? So, test is tomorrow, Valentine's, Rams, and all. This is recorded.